how long will it be till we have a humanoid assistant helping us around the house? Well, it doesn't seem too far in the future, since Google just made a big break in the field of robotics. There is a race over who can develop the most advanced intelligent machines in the tech space. Google seems to be taking the lead with its newly launched Robotic Transformer 2, abbreviated as RT-2. RT-2 is an AI-powered machine that leverages vision language models to interpret human commands and perform simple to pretty complex tasks. To this end, Google developers created a new AI model with spatial awareness and cognitive abilities, which allow it to understand instructions and predict suitable courses of action. Researchers at Google achieved RT-2 by using novel data training techniques that build on vision language models like GPT-4 to create a hybrid model capable of implementing robotic actions. Keep watching to see Robotic Transformer's capabilities and understand how Google created it. After the video, you tell us if Google is ahead of the curve in robotics. On the 28th of July 2023, a research group in Google known as DeepMind announced the release of a system that introduces a new dimension to existing artificial intelligence models: robotic actions. Microsoft made advancements with their multimodal large language model that does a great job of processing images. But now, Google has taken things a step further by housing those cognitive abilities in RT-2. Check out our video on Cosmos 2 to learn more about Microsoft's multimodal large language model. While existing vision language models can't do more than generate text and image inputs in response to a user's query, RT-2 can also send output signals to robotic limbs. That way, artificial intelligence can be applied to tasks that require physical intervention. RT-2 can take instructions like, "I ran out of water, can you refill my cup?" and translate your words to the following actions: find the cup, pick up your cup, go to the water dispenser, fill the cup up with water, return to your position, drop the cup. If you type a similar instruction on Bing Chat or ChatGPT, the language model would also think it through and type out reasonable steps. But that is as far as it gets: typing. Even if ChatGPT really wanted to help, it doesn't have the metal limbs to swing to action, nor the predictive ability to understand how to move its limbs to perform the required task. Since RT-2 integrates some action into the earlier known artificial intelligence models, RT-2 is described as a vision language action model in technical terms. The AI robot leverages natural language processing, or NLP, functions from earlier models to understand human speech, while the integrated action model relates words to physical movements. While pre-trained vision language models already exist in earlier models, Google developers had to teach the computer how to translate words into actions. Google imitated the same learning procedure for training vision language models to understand human speech, showing the computer a large dataset of images and texts. Although combining natural language processes and robotic actions is no easy feat, Google made it look like a walk in the park, with the RT-2 using this simple but brilliant technique. The vision language aspect of the system doesn't do anything different from known AI models. It receives images and converts them to sequences of tokens. The model is programmed to turn the raw data into a format the computer can work with. After performing necessary computations, the tokens are decoded into texts users can understand. Pure language models like GPT-3 do the same thing with text. This procedure allows the model to interpret images and perform various visual-orientated tasks. Next, they trained the vision language model with media files of machines performing different tasks. Large sets of such footage and captions describing the tasks it executes are fed into the model as inputs. The model's outputs for actuating its limbs are similarly represented as tokens. While training the model with robot data, they implemented additional procedures to optimize its performance, such as co-fine-tuning and output constraints. In co-fine-tuning, the developers add original web data to the initial training data set, containing images of humanoids performing specific tasks only. From their observation, co-fine-tuning made the model better at generalizing tasks, That means the Android intuitively knows how to perform tasks and identify objects it hasn't seen before, making it more resourceful in unique scenarios. Models trained solely with naive robot data are clueless whenever instructed to perform duties not included in their dataset. Output constraints is another practice carried out during fine-tuning that differentiates RT-2 from typical vision language models. At its core, RT is another vision language model with the added function of controlling an android. When the model receives a robot action task, although it can generate both natural language and action tokens, Google primed it only to output action tokens. Due to rigorous data training, the vision language model becomes a souped-up model that can take instructions and output actions to control a machine. In essence, all Google did was take typical vision language models and train them to move robot limbs in response to a command. Large-scale language models use text and pictures from the internet to learn how to understand language. In this case, Google fed the model with videos performing various tasks in different scenarios and description texts. Apparently, the model cannot perform a task if it hasn't seen videos of other robots carrying out the same activity. This learning process hints at a possible limitation, since it must have visual training of the impending task. What if you prompt it to do something it hasn't seen before? You guessed right, it would be utterly clueless. That was the case for RT-1, the first iteration of Google's AI robot project. Its ability was bounded by what it had seen on training day. Google solved this problem in RT-2 by syncing the model with web data, allowing it to learn new tricks. That way, the model became self-taught. RT-2 automatically updates its skill set every now and then, with the thousands of images and videos uploaded by online users. RT-2 can do other simple chores, like cleaning up a mess, dropping your plates in a sink after a meal, sorting objects according to color, etc. Furthermore, the AI robot can also have advanced spatial reasoning, like placing objects on specific numbers. Google did a quantitative evaluation to compare the performance of RT-2 to the earlier vision language action model RT-1, based on reasoning, human recognition, and task average. They did benchmark tests on each model while training them with limited robot data and web-scale data. For objects and tasks the model have seen in training, RT-2 and RT-1 performed similarly. However, RT-2 performed way better than RT-1 when presented with new tasks. The RT-2 model trained with web-scale data especially outshined its predecessor in problems involving symbol understanding, scoring above 75%, while others scored below 50. Okay, that's enough with the working principles. Let's talk about what Google's humanoid can do. Google trained RT-2 to do simple tasks, like dropping fruit in a bowl, grabbing objects on the verge of falling from a table. RT-2's vision and language processing can discern the difference between two objects and their proximity. It efficiently executes instructions like move the Coke container to Taylor Swift, drop the Coke can on X, move bag to Google, and pick up animals with different colors. RT-2 also flexes its cognitive prowess on more complex tasks that require spatial awareness along with recognition of objects and arithmetic, such as asking it to move a banana on the table to the number that is the addition of 2 and 1. RT-2 is capable of stunning cognitive functions like improvising. You can ask the model to pick a good substitute for a hammer, and it will grab a rock. Select a drink that's recommended for a sleepy person. Not too long ago, we discovered AI models could interpret images and text. Now, Google has shown us that AI models can decipher text and pictures and tell a robot what to do with that information. It's exciting to see technological advances in AI and robotics. Subscribe to the AI Wave and turn on your notifications, because we will follow AI technology trends as they unfold.